This is the last experiment. This is the electrical experiment, experiment number 5. Here the aim of the experiment is to establish current voltage relationship, that is the Ohm's law, for a given conductor and find its resistance and also find resistance per centimeter of the wire from the slope of the graph and the length of the wire. Here the apparatus used a metallic conductor, a voltmeter, an ammeter, a resistance box, one plug key, eliminator or the battery of the 2-volt DC and a few connecting wires. What is the theory? Already you know. If I be the current flowing through a conductor R and V be the potential difference across its ends, then according to Ohm's law, V is directly proportional to I, so that V equals to Ri, where R is equal to V by I is the resistance of the material of the wire. This is the conductor. So observation table, first you find the least count of the ammeter and the least count of the voltmeter. So least count of the ammeter is 0.05 ampere. So you find the formula. How to find the least count? The total, the reading, this is the 2 ampere divided by the number of the division, and it will get the least count, that is the 1 division's value, that is the 0.05 ampere. Similar way you can find the least count of the voltmeter, 0.05 volt, and the range of the ammeter is 0 to 2 ampere and range of the voltmeter is 0 to 3 volt. Now after connecting the all wires, when the connections are made, you see the reading of, this is the reading of the ammeter and this is the reading of the voltmeter. Okay, now I left 1 ohm from the resistance box. When I leave the 1 ohm on the resistance box, then I note this reading. This is the, in case of a ammeter reading, the number of division moves the indicator, say 12, and the number of the indicator in case of a voltmeter moves to the 22. This is 22. Okay, so then you multiply the value of the least count and you get this reading, and then multiply this is the least count and you get this reading. In this way, in this way I take the reading for 2 ohm, lifting the 2 ohm from the resistance box, 3 ohm, 4 ohm, 5 ohm, and the corresponding reading of the ammeter 0.4, 0.35, 0.3, 0.25, and in the voltmeter the reading should be 0.9, 0.7, 0.6 and 0.5. Then the resistance of the conductor is R equals to V by I. Just calculating the value, it will be 1.8, 2.2, 222. So after mean of this 5 result, this is 2 ohm. Actually the resistance here is 2.01 ohm. This is the resistance of this wire. Now to draw, for the drawing the graph I versus V, this table should be done. Here I is the ampere in the x-axis plotting, that is 0.6, 0.4, 0.35, 0.3 and 0.25, and V is the volt in the y-axis, 1.1 volt, 0.9 volt, 0.7 volt, 0.6 volt and 0.5 volt. This is the graph you see here. This is the x-axis where the current should be plotted, that is I in ampere, and this is the y-axis where voltage should be plotted, that is the in the unit volt. So I take the smallest division in along the x-axis is 0.0125 unit, and along the y-axis it is 0.02 unit. So then I plot the data here, and it will be a straight line. Already you know in the class 10, this is a straight line passing through the origin and the line of best fit. So now maximum data will be allowed on the straight line. Then I take the 2 unknown point on this graph and then I draw the gradient. Then after drawing the gradient, this is give the value of R. This R is delta V by delta I, that is the change in voltage and change in the current. So by taking the reading of this and also in the x-axis, it will be the 2 ohm again. So it is very precise result. In case of a graph, it is also the resistance of the conductor should be 2 ohm, and in case of a experimental data it is also 2 ohm. So you resistance per centimeter from graph is 2 by 50, because there is the length of the conductor wire is 50 centimeter, that is 0.04 ohm per centimeter, and in case of a graph it is also 2 by 50, that is 0.04 ohm per centimeter. It is also important practical. It will also, you note down this practical in your lab copy. This is your last practical number 5. Thank you.